May peace and blessings be on you. This video is brought to you by Physics Hunters. Hunt your physics related content in Physics Hunters. I would like to initiate with a quote. Everything happens for a reason, and that reason is physics. So always motivate yourself to learn physics, understand better, and you will achieve better. So today's topic is about combination of lenses and simple microscope. First we will talk about the combination of lenses, right? So here in combination of lenses, the first topic that I want to do it here, when two lenses are combined, what will happen, right? What about the total focal length? What about the total power? So always we have discussed about a single lens concept. What is the focal length? What is the lens formula? Everything we have done. So if we talk about the combination of lenses, let us take the example of convex lens. And these two convex lens has to be placed coaxially, right? So two convex lenses are taken and these two lenses are placed so that both are having same principal axis, right? So then, and you know that the object, this is O optic center 1 and this is optic center 2. And let me place an object. O is the object. And the thing is, let O be the point object. Let O be the point object that I am considering. And we are going to discuss any two refracted rays. One refracted rays, always it is that passing through the principal axis will have no deviation. It goes through like this. The another one will refract to the first lens, say L1, and then with respect to the lens L1, the image formation will be say I1. So this one is I1, in which I am going to take this as V dash, that is O1 will be the object distance which is towards left hand side. This one will be U, and you can be able to see that O1 I1 will be the image distance V dash, right? And the image is formed at V dash. Now additionally you are placing the lens L2. So if it is about to pass through the lens L2, then it is increasing a convergence property. So with the respect to the lens L2, the refraction will happen in such a way that the additional convergence will try to make an image over here, say I. So the image formation actually according to the lens L1 is I1 and with respect to the lens L2 is I. So this is the final image formation. So this one will be taken as the V, the image distance, the final image formation. So you can be able to see that this one will be the let V be the final image distance, right? So this is the concept in case of your combination of a lens. And as we know very well, the lens formula, by lens formula 1 by V dash minus 1 by U is equal to 1 by F. For the lens L1, the image distance is 1 by V dash minus 1 by U, and the focal length of lens L1 is taken as 1 by F1. This is equation number 1. And you know that now the image is formed after the refraction due to L2, that is the object distance. Like your object distance be U, but your image distance will be O2I, which is nothing but according to the lens L2, the object distance, that is the object distance for the second lens. The object distance for the second lens will be the virtual imagination, that is the virtual distance of V dash. This V dash will be the virtual object distance for the lens L2. By this thing, if you want to rearrange this lens formula, the final image will be 1 by V, and then the object distance will be 1 by V dash, which is the virtual object distance. due to this V dash is due to the lens L1 and the focal length is 1 by f2. Now we have two equations and you can add two equations in such a way, left hand side and right hand side separately. And the first left hand side will be 1 by V dash minus 1 by U plus 1 by V minus 1 by V dash. And in the right hand side it is 1 by f1 plus 1 by f2. This 1 by V dash minus 1 by V dash is getting cancelled, and then you have 1 by V minus 1 by U, which is equivalent to 1 by the reciprocal of focal length, right? Because this 1 by f1 plus 1 by f2 is taken as a combination of the two focal lengths and can be written as 1 by f, in which I can take it as third equation. What is this 1 by f? The combination of focal length of the lenses, 1 by f1 plus 1 by f2. So capital F can be f1 f2 divided by f1 plus f2, right? And if you see the total power, which is nothing but the reciprocal of the focal length, can be P1 plus P2, and if there are n number of lenses it can be added, so that adding all the powers together you will be getting the total power. So this is your power formula with respect to the combination of the lenses. And if you have many lenses that are combined together, the total magnification is nothing but the product of individual magnification. Just know the formula for the total magnification if you use more than a lens, right? And here if you see about the important information to be noted for playing the formulas, that is your problem. If your focal lengths are equal, f1 and f2, if you use in the combination both the focal lengths are equal, the total focal length, the total combined focal length will be infinity. So the combination of this type will lead to the similarity of a plane glass concept, right? So the resultant focal length is in such a way that it behaves like a plane glass. And for case 2, if the first focal length is greater than the second focal length, for total focal length will be negative, so that it leads to concave, right? So if this will happen, so if it is happening that negative and the negative focal length, which means that it is concave, this will happen when the focal length of convex lens is larger, right? And then the next one is case 3, f1 is lesser than f2, so that the total combination will be positive, and this leads to that the total combination will be convex lens, right? And this will happen that if where focal length of convex is smaller. So this, if you keep it in your mind, you can apply it in the conceptual question or in the problem. So this is about the combination of lenses. So the next topic is about simple microscope. The simple microscope consists of a converging lens, that is your convex lens. It consists of a converging lens of small focal length, right? It is just a resemblance of your magnifying glass, right? So how a tiny object is zoomed out, that is your simple microscope, right? And we are going to take the image formation in such a way that when the object distance will be between the focal length and optic center, so that you will be getting a virtual and erect image, so that your resultant image will be magnified. Your resultant image will be magnified, which is formed at the least distance of distinct vision. The least distance of distinct vision, right? So let us try out in the diagram. First of all, the optic center is marked and this is your focal length, and you can place your object between the optic center and the focal length, and you can try that the first rule, a ray parallel to principal axis after refraction passing through the focus, and the second rule is passing through the optic center. Both will not converge after refraction, so that it will try to form, it will try to appear to converge at the same side of the object, right? So this is your object AB, and this is your image A dash B dash. So the object is magnified and virtual and erect image is formed. And as you know well, the eye that is going to be like, the eye is held closer to the lens, closer to the lens. So we have discussed that AB be the object, right? So which is placed between optic center and focal length and perpendicular to the principal axis, so that the virtual image and magnified image will be formed as A dash B dash, which is the image. And we know that this OB dash, which is nothing but capital D, that is the least distance of distinct vision, which is the image distance. And the magnifying power M will be that magnifying power of simple microscope is defined as the ratio of the angle subtended by the image divided by the angle subtended by the object when they are at the least distance of distinct vision, right? So that if you make out the triangle here by looking into the diagram, so that AOB, right? Let us consider that the triangle AOB, right, which is nothing but, we have to mark it as image formed by the object. So this can be written as say alpha, and you can be able to see that the image formed by the, that is the angle formed by the image, the angle formed by the object as well as the angle formed by the image. If you see that AOB, right, and if you see A dash OB dash, which both of them, with respect to that, we will consider this as beta first, and then let us have a reference line over here which is called as A1, right? So we can compare that this A1 with respect to the A1. If you draw the line to the optic center, that angle will be alpha. So with respect to the same reference line, that is your A dash OB dash, which is beta, image formation, the angle is beta, and object is A1 OB B dash, which will be alpha. So now we can write those angles in such a way that A1 OB dash is equal to alpha, and AOB, which is equivalent to A dash OB dash, is equal to beta. According to the magnification concept, that M is nothing but the angle subtended by image to the object. So beta by alpha, which is nothing but it is tan beta by tan alpha, and angles can be approximated. For small angles, tan alpha or tan beta can be approximated as alpha and beta. Now take the triangle AOB, which is nothing but, if you take a tan beta over there, opposite side by adjacent side, AB by OB. And if you find out in the angle triangle A1OB dash, in which if you find out tan alpha there, it is A1B dash by OB dash, in which if you compare this in the diagram, this A1B dash will be same as the length of AB. So you can also take this as AB by OB dash. So here, if you want to find out the magnification, which is tan beta divided by tan alpha, which is, you can write it as tan beta as AB by OB and tan alpha is AB by OB dash, right? So that you can be able to cancel AB in both the sides, and you will be getting the answer OB dash by OB if you take the reciprocal. OB dash is nothing but image distance, which is towards left hand side, because the image is formed as virtual, and object distance is minus u. So you will be getting V by u according to the sign convention. So if you find out, apply the length formula here, 1 by f is equal to 1 by v minus 1 by u. In this equation, according to the length formula, multiply v throughout the equation for our convenience. So you will be getting v by f is equal to 1 minus v by u. What is this v by u? V by u is nothing but the magnification that we obtained. So you can write it as v by f is equal to 1 minus m. So what is m here? 1 minus v by f. What is the image distance here? The least distance of distinct vision, which is towards left hand side. So your magnifying power formula will be 1 plus d divided by f. This is a formula for the magnifying power of simple microscope. Magnifying power of simple microscope. So apart from that, if you compare, if you see to the equation here, as focal length decreases, so you have to use a shorter focal length, your magnifying power will be increasing. So smaller the focal length of lens, greater will be the magnifying power. So I would like to end the video by saying that, by insisting the Einstein quote, each one of you should be curious in knowing the things. Einstein says, I have no special talent, but I am passionately curious. The curious things will make you the things to understand it better, and you will do wonders. Thank you.